So let's start with simple geometry in Rhino. We can draw any shape that it comes from line or close polyline. We place them on the top level. In this case is roof or the ending of the level. And we have to specify the elevation of the ground. In this case is 0. Once we do this, it's gonna generate the adjacency cluster. We can always manually add aperture by geometry, where we specify geometry, and within the distance range it will generate aperture for this model. We can always use, and this is the most versatile component, inspect. Inspect is the component that can check any some object. So we can connect, we can show all the possible parameters, and now we can see our panels. In this case, I'm gonna show exposed to sun and internal panels. And if we are fine with this, we can remove all unconnected. In this case, we have this nice, neat object. Because it's one space, we don't have any internal panels. So this is the first approach. The second approach is, again, we can build the geometry, but we can do more shape. So I just draw two set of geometries and cut them. We also generate a model, and we can the same way inspect. In this case, we can have automatically recognize internal panels, ground, external, and exposed to sun. Exposed to sun is good because we can see always from the bottom what's happened. We can always send stuff to Revit. In this case, I'm just connecting our AGC cluster and sending this to Revit. So if I click here, we should see our model behind here in Revit with the windows and all the models set up. The next method and a different way of approach, I created this kind of multiple outline of the top ending of the levels, and here we can see our model, and now we can improve the way of implementing the openings, apertures. We can do by ratio as a fixed item to all of them. However, the more useful one is this one, where we can also specify by azimuth. So we could do as many as we want domain with the ranges, and we specify percentage. So you can see we have 0 at the north, and more depends on the orientation. Okay, and if we're working with this kind of enclosed shape like boxes, and we have much more accurate geometry, we can use a Topologic. So here we generating the panel, creating the panels, and we automatically recognize roof, walls, and floor. And we're just gonna run through Topologic for recognition. Once it's finished, we're just gonna create cluster, and we can again add aperture. So it also works for this non-rectangular shapes. So here we can see the inspect, and this is our aperture of those walls, less on different angles. And we can always show and bake our geometry with aperture closed or open. This is very useful if we want to see or use the stuff for daylight. I will just bake this geometry, and as we can see, it bakes with the aperture open. Okay, so once we have our AGC clusters, I will just come back to our initial case. So this is our initial model with one space. We can connect this easily with tasks for the dynamic simulations. So here I'm creating analytical model where I'm just adding location and building level information, and I will just run it. Then I'm generating GBXML, importing this into tasks, fixing normals, and do the generic setup on the import. After that, we update the data run the shading calculation, and run the dynamic simulations. So we are heading towards this kind of fully automatic approach and simulation. So here we have, we can see all the steps. It is finished now. So I can try to open the files. So this is our TSD, which is the results file after simulation with the hourly split. If I go building element, so we can see already our model imported here. I will close this case and we try to do another one. So let's try to select maybe this one from Topologic. Okay, the funny shape. Okay, and if I run this again, it will repeat the process and we should see the simulation for this particular model. Okay, I think it should finish now. Yes. So if we open our results file, yeah, we can see our model now, the shading. Obviously, we have access to all this kind of hourly data and the simulation. Okay, thank you very much.